Now that we know the basic vocabulary of statistics and know how to collect data, we're actually ready to start displaying some data. Our question for today is, how do we display data visually? And we're going to look at two main ways to display data. The first way is going to be with what's called a histogram. A histogram shows us frequencies over intervals. And a histogram can really give us an idea of the shape of our data. Let's do a quick example here. It's going to be easier to talk about a histogram with an example of a histogram. So here's a scale, 1, 2, 3, 4. Up the vertical axis, the y-axis is always labeled frequency. And then the x-axis is going to be some type of label of what we're actually looking at. Maybe we're looking at the number of TVs in a home. And I'm going to actually start at -0.5. I'm going to come over here to 1.5, 3.5, 5.5, 7.5, 9.5, and we'll end at 11.5. First box, we're going to make 1 tall. The next one, we're going to go up to 3. The next one, we're going to start at 2. The next bar will start at 1. Then we'll skip a space and put a bar at 1. I'm also going to give this a title. Let's title this the number of TVs. And this picture is an example of what you would expect a histogram to look like. A couple things that I want to note. The bars on a histogram touch. They come down on the interval numbers. Not in between, but right on those numbers I labeled. And they show frequency in a range. In other words, if I color this second bar green here, what that second bar means is that there are 3 values, or 3 people who reported having between 1.5 and 3.5 TVs. Between 1.5 and 3.5 are the numbers 2 and 3. So the numbers 2 and 3 all went into that bar. Now, it's impossible to have 1.5 or 3.5 TVs. And that's what brings up the second point here, point B. If possible, and it's usually easiest with discrete data, never have a bar come down on a value. In other words, if I'm talking about the number of TVs, I don't want this to come down on 4 TVs. If a bar came down on 4 TVs, I wouldn't know if that 4 goes in the left bar or the right bar. So instead, I make sure my bars come down staggered from actual data values, in this case, by 0.5. And you also notice I took care to give a title to my graph and labels for the x and y axes. Title and labels are important. So now that we kind of know what a histogram is and what it looks like, showing frequencies over a range, let's look at how to make a histogram. First, we need to decide on the number of bars. Once we decide the number of bars, we'll use this nice little formula where we take the high number minus the low number, and then divide by the number of bars. And then whatever that number is, we will round up And that will give us the bar width, how wide each bar should be. Now, it's important to note we always round up. If it's 3.1, we'll still round up, and the bars will be 4. In fact, if it's 3.0, we would still round up to have 4 bars of width 4. We always round up to the next number after this division. Next, we need to decide on the starting value. What I usually recommend we do to decide on the starting value is do 0.5 before the lowest number. In my TVs example, 0 is the lowest number of TVs, so I went 0.5 before that, so I'm staggered, and the bars won't come down on that. Then it's helpful to make a frequency table. Like we saw in section 1, with ranges. With the ranges that we found in parts A and B here. And we can use that frequency table then to build the histogram. So if that's the method, let's see if we can go ahead and actually do that with an example. The number of miles (20 students) commute to work is below. We are going to make a histogram with 5 bars to represent the data. And our data here is going to be 4, 6, 6, 7, 11, 13, 18, 18, 18, 21, 24, 26, 27, 35, 36, 36, 42, 43, 45, and 49. So for our bar width, we need to take the high minus the low divided by the number of bars. So the high is 49 and the low is 4. 49 minus 4 divided by the 5 bars is 9. Now it's exactly 9, so I have to round that up to 10 is my width. Always round up to the next whole number. Otherwise, your last values won't be included in the last bar. Now we can decide on our start values, or our ranges. So for our x values, to start with our graph, we're going to start half a unit before the low value of 4. So half before 4 is 3.5. And we're going to go up 10 to 13.5. The next range is going to start at that 13.5 and go up 10 to 23.5. Then we have 23.5 to 33.5. And I'm running out of space, so I'm going to scroll up a bit. 33.5 to 43.5, and 43.5 to 53.5. Those are our ranges. Now we just need to find the frequency inside each range. 3.5 to 13.5. There's 1, 2, 3, 4, 5, 6 numbers. 13.5 to 23.5. We only have 4 numbers. Then you see 23.5 to 33.5. There's 3 numbers. 33.5 to 43.5. There's 5 numbers. And 43.5 to 53.5, we see 2 numbers. Now that we have that frequency table, we're ready to build our histogram. Starting at 3.5, my next tick mark is 10 later at 13.5, then 23.5, 33.5, 43.5, and 53.5. Our frequencies go up to 6. 1, 2, 3, 4, 5, 6. The first bar is 6 tall. The second bar, touching it, is 4 tall. The next bar, touching it, is 3 tall. The next bar, touching it, is 5 tall. And the next bar, touching it, is 2 tall. And now my bars show the frequency within each of those ranges. Now I still need a title. We're talking about miles driven to work. It's a good title. Our x-axis is in miles. And then the y-axis, going from 1 to 6, always shows my frequency. And there's my histogram. Now with histograms, it's important not just to be able to draw the histogram, but we also need to be able to describe the shape of the histogram that we end up with. So a couple notes here on some vocabulary you can use to describe the shape of a histogram. And now with real-world data, it's never perfect. Histograms are never perfectly any of these shapes, but they tend to be close to one of these shapes. Not always, but generally, a common shape we'll see is what's called the uniform shape, where the bars are about the same. So just a quick sketch here. You might see bars that they're not quite exactly the same, but they're pretty darn close. We would say that histogram is uniform. They're all about the same height on all the ranges. Another word we should know is what's called a normal shape. The normal shape is taller in the middle and shorter on the edges. What a normal shape looks like is it generally starts short and gets taller until the middle. And then after the middle, it starts getting shorter again. It's also called the bell-shaped curve, where it goes up and then back down. The opposite of the normal shape is what we would call the V-shape. And that is shorter in the middle and then taller on the edges. So that's when we have a tall edge that gets shorter, and then it comes back up and gets taller on the outside. And you can almost see that V shape right on top of those bars. In addition to the shape, we can talk about its symmetry. We say a graph is symmetrical if it's basically the same on both sides. So if we go tall and then shorter, it's going to be the same thing on both sides. You notice that's the same as the V shape. It's also symmetrical, the same on both sides. And we can combine these different descriptive words together to come up with a detailed description of a histogram. Then we have this idea of skewedness. Skewed means it's not symmetrical. And we describe the unsymmetrical part where the extra stuff is. Skewed right means it's not symmetrical because we have extra stuff, for lack of a better term, on the right. So that's where we're trying to be symmetrical, right? But then on the right side, there's all this extra stuff, and it kind of goes down a lot slower. That extra stuff means it's skewed right. And you might expect the last term then is skewed left, where the extra stuff is on the left. And that's where we've got all these extra little short bars on the left before it starts growing and giving us our what would be symmetrical shape. So that's histograms. We can draw them to show the shape of the data. We can describe them as uniform, normal, V-shaped, skewed, symmetrical. Really can help us visualize what our data set looks like. A second thing we can do, though, to describe our data visually is to draw what's called a box plot. And a box plot shows the spread of data with what is called the 5-number summary. Five-number summary is made up of 5 pieces: A, B, C, D, and E. The 2 easiest to find are the minimum and maximum. And then right in the middle of them is what is called, we'll put it on C, the median, or the middle when the data is in order. So the median cuts the middle of the data, and then we've got the top half and the bottom half. In the bottom half, we're going to find what's called Q1, or the first quartile. Which is the middle of the lower half. And similarly, Q3 is called the third quartile, which is the middle of the upper half. So the quartiles and the median really divide it into quarters. Now, there's a little caveat with the quartiles and the median. We said they're the middle values, but if there are 2 middle values, what we'll do is we will add them together and divide by 2, giving us the middle of the middle. Once we find that 5-number summary, we'll usually represent it visually with what's called the box plot. The box plot splits the data into quarters. And to do that, we put Q1 and Q3 as the edge of the box. And then we draw whiskers out to the min and max values. And finally, we use a dotted line for the median. And so what we end up with is there's some number line down the bottom. And then floating above that number line is the box showing where the quartiles are, Q1 and Q3. Whiskers out to the minimum and maximum values. And then a dotted line for the median. And each part of the box represents a quarter, or 25% of the data values. The box, then, is the middle 50%. The whiskers are the outside 50%. And we can make some visual conclusions about how our data is spread out. Let's see if we can make a box plot. Going back to our example with the commute time, that list of numbers again for us was 4, 6, 6, 7, 11, 13, 18, 18, 18, 21, 24, 26, 27, 35, 36, 36, 42, 43, 45, and 49. Now, if this data was not in order, it would be essential as a first step to put the data in order. Fortunately, ours already is in order. We know there are 20 data values. So 20 cut in half is 10. We're going to have 10 below and 10 above. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Cutting in half, 10 below and 10 above, sticks us right between 21 and 24. Because it's right in the middle, we add those numbers together and divide by 2 to get our median value, which is 22.5. Then we can go after our quartiles. Our quartiles are in the middle of the bottom half and the top half. Well, the bottom half has 10 values, so we're going to split 5 and 5, which sticks us right between 11 and 13. Again, because there's not one value in the middle, we'll add those together and divide by 2. 11 plus 13 divided by 2 gives us our Q1 equal to 12. For the upper quartile, again, we're going to have 5 data values on each side. Sticks us right between 36 and 36. When we add those together and divide by 2, the third quartile is 36. Also include our minimum value of 4 and our maximum value of 49. And we're ready to make our box plot showing the spread of our data. We should make every attempt to make this box plot to scale. So if I count by 6s, starting at 3, we'll have 3, 9, 15, 21, 27, 33, 39, 45, and 51. Notice those are about the same size apart from each other. My box is made from the quartiles at 12 and 36. So we connect our box. The median's a dotted line at 22.5. The whiskers go to the minimum of 4 and the maximum of 49. And we have our box plot. Of course, any graph needs a title, so we can title this commute time. And label the x-axis, maybe time in minutes. And we have our box plot. Now, normally the box plot would all be one color, but I did color coding to show where all the pieces came from in this example. And just like we can describe the shape of our histograms, we can also describe the shape of our box plots. And there's basically three ideas here. One is the idea of being spread out, where we have a wide range of values. This would be a big box plot. Covers a large range of values. That means the data is not really close to each other, not close to the median, not really close to anything. It's all spread out. The opposite of being spread out is to be clustered together, where we have a small range of values. And this is going to give us a really tiny box plot. Everything's really close to each other. And often it's beneficial to split our description into the entire shape and the middle 50%, or the box. For example, I could have a box plot that looks like this. And we could say, overall, the data is spread out. But the middle 50% is clustered together, because the box is small compared to the rest of the data. So that's what we're looking at today. Histograms and box plots. Practice making them, practice interpreting them, describing them. Take a look at some of them on the homework. We'll work with these a little bit more in class, and we will see you then.